Alright, we begin a very important section in Chapter 1, Section 3 on functions and relations. This is a key idea. Unfortunately, when I was in school, my teacher was going over this particular topic, and I just recently had a change in my seating location in the classroom, and I sat right behind Janine Mitchell. And unfortunately for me, I spent more time watching Janine Mitchell in front of me than I did watching the board and what was going on with functions and relations. So hopefully there's no Janine Mitchell or equivalents sitting around you while you're watching this video. A relation in x and y is just any set of ordered pairs x, y. It can have a single ordered pair, it can have infinitely many ordered pairs. If you take all of the x values of the ordered pairs, you get what we call the domain of the relation. And if you take the set of y values of all the ordered pairs that are in the relation, you get the range of the relation. Two very key ideas, domain and range. And I have an example here, a simple one. I have a table shown. It says for this particular table, write the set of ordered pairs, set, so set notation, braces, that defines the relation. Well, I have x, y's here. I have four ordered pairs that I'm going to write out as the ordered pair -3, -4, the ordered pair -2, 0, the ordered pair 5, 3, and the ordered pair 1, 0. Now you can write the four ordered pairs in any order. Sometimes people write them based on increasing or decreasing and increasing on the x values. I didn't quite do that here. It doesn't matter. That's the four ordered pairs that make up this particular relation. The domain, and a lot of times for domain we'll use a capital D, would be all the x values, -3, -2, 5, and 1. I usually put these in increasing order, even if my ordered pairs aren't quite written that way, -3, -2, 1, and 5. And my range, and we usually use a capital R for range, would be all the y values, which would be -4, 0, 3, and 0. Now 0 is used twice as a y value. You do not write it twice. You just write them out one time, -4, 0, and 3, and I also like to put these, if I can, in increasing order. So this is my relation, and this is the domain and the range of this particular relation. Now, if all we dealt with was relations, it'd be a little bit boring because it's any set of ordered pairs. We need a restriction on what our ordered pairs can be, and that brings in the idea of what we call a function. A function is a relation, but it's a special type. It says y is a function of x if it is a relation such that. This little weird symbol means such that, and then there exists, or I have to take that back, for all, not for there exists, for all values, actually values of x in the domain, there exists exactly one value in the range. This is just little notation shortcuts in math. Good old Dr. Label showed me those years ago when I was in his abstract algebra class, such that for all or for every, there exists. Okay? So what we have here, the restriction is, don't get caught up on the weird notation. The restriction is here, for every value in the x, there's exactly one value in the range. So you can't have the same x value used twice with different y values. Now, if you look at the example that I have down here, -3, -2, 5, and 1. All the x values are used exactly one time. Therefore, this relation is also a function. Let's see if we can determine that with these two examples. Determine if the relation defines y as a function of x. So we're just going to answer yes or no. So I look at just the x values. All my x values are different. Yes, it's a function. Okay, it does define y as a function of x. Over here, I look at just my x values for this example, and I notice that I have two x values that are the same. They're both -3, and they have different y values. So these are two different ordered pairs, but they happen to have the same exact x value. So this is not a function. This is a relation, but it is not a function. If you want to think of it graphically, and it's going to be a little difficult for me to sneak a graph in here, but the idea is that if I was to graph these two ordered pairs, I would have -3 here, let's set a scale, -3, 2, and -3, 1. Notice that these 2 points are one right above the other. They're on the same vertical line. The vertical line x equals -3. So when that occurs, when you have this repetition in x values, graphically you'll see the points lining up and being on the same vertical line. In fact, that leads us to a really important test to determine if a relation is a function when not given just sets of ordered pairs like this, but given actual graphs, and it's called the vertical line test. The vertical line test says, consider a relation defined by the set of points xy graphed on the rectangular coordinate system. Fancy, fancy, fancy. The graph defines y as a function of x if no vertical line intersects the graph in more than one point. Which means that if I can draw a vertical line that crosses my graph, even if it's just one vertical line that does this, that crosses my graph in 2 or more points, it is not a function. Look at the first example that I have here. If I draw, and I'm going to try to freehand a vertical line here, if I draw a vertical line, hopefully you can see that, do you see how it intersects the graph twice? This is not a function. The vertical line test tells me that this is a relation, but not a function. Whereas in the second graph, no matter where I draw my vertical line, I never cross it more than once. So this one is a function. Now on this last example, it's a piecewise defined function. I don't have the equation written out, but I try to draw this in such a way that these 2 points here and here we're on the same, well, that wasn't a very good vertical line. That's still not a very good vertical, there I hit it. On the same vertical line here. This is the only vertical line that intersects the graph in 2 or more points, but all you need is 1 and it ruins it for the whole graph. So this one is also not a function. So the vertical line test, if you remember that from your algebra days, that's good because we are going to use it from time to time.